We're not clear to start yet. 1 second. Hello, everyone. Welcome to DevX. Yeah, claps. Hosted by Edge. Secure your freedom, open source self-custody, Edge Wallet. We are a community of like-minded developers and software engineers fostering community through events and open source projects in San Diego, California. That's who we are. Organizers include me, Sam, Zane, and Ezekiel, who is currently missing. But, you know, he's here. In our hearts. And yeah, hosted by Edge. Sam, do you want to talk about Edge?
All right. Hello, everyone. So a little bit about Edge. Full disclosure, I'm one of the software engineers at Edge. And as a software engineer, also a bit of a hacker, as you can tell. Not the best solution, but the quickest solution. We had a little bit of technical difficulty. So if anyone's walking by, just mind the red tape. We don't want the projector to go out. So, but anyway, just a quick joke about that. Edge, what are we? Edge is a crypto app or crypto wallet. We focus on privacy, self-custody. If anyone's familiar with crypto, you probably know how important those aspects are of crypto, so that's what we focus on. We're kind of cypherpunks at heart, so you'll find all of what we do is really aligned with that ideal. So if you don't know about crypto, feel free to ask me. I will rattle your ear off with that. Also, Edge is open source. That's very meaningful for all of us developers. We can check out the GitHub repo at github.com/edgeapp, and you can view all of the cool things we do in there. And if you feel like contributing, ask me as well. I'd love to help you out. So big shout out to Edge. Thanks for hosting the space and giving us this medium in which we can all meet.
Thank you, Sam. So facilities, Wi-Fi, Edge guest. The password is I like big bits, all lowercase. Restrooms, they're out that door down the hall to the left. There shouldn't be a code, but if you do need one, it's $15.95. Oh, install update? Not right now. Skip, ram later. We're on Luma. Check us out at Luma/DevX Network with all the proper capitalization. And here's the agenda. We ate some food. That was great. Already passed. Now we're going to do speaker presentations. There'll be 2 presenters today, I think. Yes. After that, we're going to do a time of community announcements. That's a time for you to come up and talk about, for about 15 seconds, something that's really cool to you or something you're interested in or a project that you have or even another meetup. Then after that, back to food, hang out, coding. That'll be great. And then we close at 4. So our speakers today are James Lawrence on the music theory and generating keys with Python. Very good. And then Getting Started with GitHub Actions by Jonathan Lewis. And to that end, James Lawrence, please come up. Give him a hand, everyone. This is it. The real test.
Is this good? Yeah. Okay. That's my voice on the mic. Okay, cool. All right. Okay, cool. So, understanding musical keys. So, like I said, 12 notes in Western music. We can create only 7 notes that are actually going to go well together, depending on the song that we're using. So, not a lot of options, right? And that's why it's important that we understand how they work together. Okay, so first, most important key in music, not necessarily the most important, but you can tell that I'm a little bit of a piano player, and we're going to use a piano because it's a beautiful instrument. It lays out music flat, whereas guitar doesn't. So what we're looking at here is we're looking at 1 octave of the Western music scale. It moves from C to C, goes through C, D, E, F, G, A, B, and then back to C. These are all the white keys on a piano. If you go over to any piano and you start over at the left-hand side and you walk up the white keys, this is the pattern that you'll encounter. Next set of white keys up, same pattern, same pattern, same pattern, same pattern. Here's the biggest thing for us on this little instance, right, is the distance between the white keys and the black keys, okay? So if we take this and we start with this little C back here, we move to D, we notice that we skip this black key, that gives us 2. We move to E, we get 2. We move to F, no black key, we only get 1. Now this isn't between black keys and white keys, this is just the way that the piano is laid out. It's so simple that we can just move across the white keys to get this pattern that's going to be very important for us later on when we're plotting all of these keys. So back to E, E to F, 1, G to A, 2, G to B, 2, and then B to C, 1. And if we plot that out on E major, we see the same sort of pattern here on piano. So this is E, you're just going to have to believe me that this is E. And then we move to F sharp, then we go to G sharp, then we come back down to A, then B, C sharp, D sharp, and E sharp. So again, like I said, same pattern. So now we have E major, or now we have major, and we have minor. So that's pretty cool. Here is a really interesting little diagram. If you've never been familiar with this is called the circle of fifths. Fun little fact, this actually helps composers compose music. It shows the relationship between keys. If you've ever, I can't remember the jazz musician, Big Steps, his musical composition is basically showing, if you watch the diagram, it's showing how far you can actually step across this thing. DJs use this device as well. When DJs are using this, they call it the circle of fifths. Not every DJ actually knows that this is what they're using when they're using it, or I'm sorry, they call it the Camelot wheel. When DJs are using it, they call it the Camelot wheel, and they replace the letters with numbers and letters, B2, C3, and stuff like that, and it allows them to move through music. So if you've ever thought about like, oh, this DJ really actually knows what he's talking about, or this DJ is really good at blending these songs together, and I had no idea that they had relationships that were so similar. This is the device that they're using to see where they are and where they're moving to next. Okay, so a little bit of an explanation, but here's the point that's going to be important to us. C major, right over here on the outside. It is right above A minor. And you can see here, outside is major, inside is minor. So what this relationship is showing us is the difference between relative majors and relative minors. So if we go back up here, you see that we're moving to get C major all the way across the white keys from C to C. Well, because A minor is the relative minor of C major, that means that if we start on A and we just go up the white keys, we get the same thing for minor. So you're just going to have to believe me here that this is A right here where the 2 is. So again, A, B, C, D, E, A, B, C, D, E, F, G, and then back to A. And again, we get another pattern, 2, 1, 2, 2, 1, 2, 2. I know there's a lot of information, but you know, you guys are smart. You'll figure it out. It soaks up like a sponge sometimes. It took me a long time to figure this stuff out. You got to practice with it and play with it. But E minor, same thing. If we just choose E and we move, we have 2, 2, 2, 2, 1, 2, 2. So now that we have our equation for both major and minor, we need to learn just a little bit more about accidentals. The way music is constructed, we have these same the same notes that are across the bottom here in the white keys. Black keys actually represent sharps or flats. Normally in music, when we're just not necessarily talking about anything, we just call them flats. So C sharp, D sharp, F sharp, G sharp, A sharp. But when we start to move the keys around, so when we start to use a different starting point and a different ending point, you can see here towards the bottom of the circle of fifths, becomes, we're talking about A flat. Well, A flat is really just, where are we? A flat is just G sharp, right? D flat is just C sharp. And that's important for us when we're creating musical keys, because if we don't do this right, then people are going to be very upset with us. Okay, so rules for creating keys. Can't use the same letter twice. If we have a key with C and C sharp, it can't be C sharp, it has to be D flat, for example. And then also, if we start with sharps, we want to keep using sharps, or if we start with flats, we want to keep using flats. Okay, so, and there's my email, just in case you were wondering about that. All right. So, all that talk about music and stuff like that, finding all this stuff on the piano, comes down to a very simple script that is only this long. Show you what the output is and how we use it first, and we'll step through it real quick. So basically, we've just created a function called generate scale, and we're just passing it two parameters. Our root note, our starting note, and then also major or minor as far as what we're looking for. Now, if we run this, it gives us the output that we would expect. So now, because we know C major, we know C, D, E, F, G, A, B, C. Perfect. Got it. A minor down there at the bottom, A, B, C, D, E, F, so on and so forth. E major, let's go for broke. Let's see if E major is the same. I never checked that. I was hoping to check it. Okay, E, F sharp, G sharp, E, no, that's E flat major. I'm sorry, that's E flat major. Let's create another one here. Let's do some live coding. Do 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 do. Do do do. Let's say we want E and we want major. There's no N in major. Sorry, I forgot my reading glasses. Oh, that's A minor. What? Because I have it. Yeah, I have it labeled as. Yeah, thank you. A major. But I'm scared. I do want E major. Yes, thank you. Yes, thank you. Ah, there you go. This is great. This is demo time. Like they said, you don't have to be at any skill level. Oh, thank goodness. I was scared there. So yeah, we're on the right track. We've got 4 flats for E major. So let's just walk through this little script real quick. And so 2 things that pop up. One, this little data structure that we have, this gives us the ability to walk through all of the sharps going down the left-hand side, and then all of the flats going down the right-hand side, also giving us the natural notes in between those sharps and flats. Then we have our equations that we've added for major and minor, 221, 22221, and so on and so forth. And as you guys probably, oh, sorry, go ahead. No, thank you. I think I appreciate the offer, but at this point in time, I'm aiming at shapes. Thank you. But I'm pretty good at aiming at shapes because I don't use my reading glasses most of the time like I should. So, all right, here we'll up it there. There we go. That'll make it better for everybody. All right. So, and like you guys have probably already guessed, we have our pattern and we have our pattern for our notes, and we have our equation for how long we're going to step through this array. start with grabbing the tonic note, which is where we're starting, because we'll want to glue that back onto the end of our loop. We're just doing a little bit more of indexing and stuff like this, and then here we get to stepping through our array with a little equation that actually is very handy that I did not know, and I should have known this by this point in time in my career. But I thought that this was kind of sort of just a sweet little way of making this little line of code right here makes this little data structure continue around in a circle. It's a continuous circle as long as this outer loop works. This little inner equation of, of current step plus next step modulo length of whatever I'm doing, it automatically gives me the first array. So I was stoked on that. That was definitely a pleasurable thing for me. So, okay. So then we have to choose whether or not we have the right accidentals, whether or not it's flat or sharp, and we're just kind of sort of moving through those. It's not that hard, because once we've gotten on a path, because of our data structure, we can just kind of sort of keep on that path. We don't necessarily need to switch back and forth. And then last thing, we're putting back together our, we're checking to whether or not we've used our lists, our notes already. So possible notes is an array of notes that we've already used, or yeah. And then just putting back on the tonic note and returning our scale. So yeah, this application is going to be a little bit, this is just a little demo app, and I'm going to continue to work on this. It's going to be a music app that's probably going to be Flask related, and I'm just going to continue. Like, I want to go back and do the circle of fifths and have that be an interactive thing. But yeah, guys, any questions? Yeah, thank you.
So who's your demo for this, your demographic?
Me. Yeah, me, and also trying out public speaking. So I haven't done a lot of public speaking, and I know that I am looking for a job. So this is, my a little bit of getting into that foray. But for this, I would say, I find this interesting. I didn't learn music until just recently, only around 3 or 4 years, 5 years ago. Pandemic time. Yeah, pandemic time. 5 years ago. Simple math. When I started to learn music, I was like, oh, I actually understand all of this stuff. Like, this isn't complicated. Like, Axis of Awesome, the same code when they were like, oh, every pop song is the same chord progression and stuff like that. It was like, how could that actually be? And they're kind of lying to us a little bit, but yeah. So my core demographic is me, or just anybody who enjoys music and wants to learn more about like the functional part of music, not necessarily like, oh, this is, yeah. So maybe we'll get into microtonal stuff. Yes?
Suggestion, if you want to make it easy access, make music, a steel tongue drum.
Steel tongue drum.
Same shape as the circle of fifths.
Ooh, that is super cool. Are we talking about this?
It sounds like
Yeah.
a round xylophone.
Yeah. Are we talking about the round drum, like for oh, that's that's super cool. I had no idea. Sorry, go ahead. Yeah, sure. I can put my email back up, absolutely. You can spam it too. There we go. There we go. Full screen. So yeah, yeah, that's awesome. Thank you. Yeah. All right. Are we good? Yeah, thank you. Oh yeah, sure go.
What will be the end result when you run the Python script?
Oh, so the end result is basically this, sorry. Hey, come on. There we go. So this little information right here, so yeah, we're basically able to put in, this last line tells us that if we call this function E, and we want the major key signature, then E, F sharp, G sharp, A, B, C sharp, D sharp, and E are all going to work together in this musical composition that we're working for. So this is what is called a key signature, and it's a subset of those nice sounding notes with each other. So actually, that's kind of sort of a fun thing. Actually, this is one of the things. Make yourself look like a genius. If there's ever a song that's in C major and you don't even know what you're doing, just start playing around with the white keys. You're going to sound awesome as long as you end on C. Just so that you know, that's how music works. So yeah. You can fake being a piano player. If you know that it's in A minor, just mess around with the white keys. You're gonna look like you're a piano player. What's that? You need to end on A. So there you go. Yeah. Wherever you start, end on A. You start on C, end on C. That's kind of sort of another fun thing about tonal. We always feel like we're at home where we started from. So if we start on A, we're just automatically, as human beings, we're gonna feel like we're at home when we come back to A. If we started on C, we're gonna feel like we're back home when we come back to C. Doesn't even matter if it's the same A. If it's this A or that A, it's gonna feel like, oh, I finally made it, yay. Yeah. So yeah. Sorry.
How'd you come up with the tricky little function?
It was AI generated. Yes. I'm gonna come to that. Yes, it was AI generated. Here's why I'll come to this. I did not come up with this data structure, but I knew what I wanted, and what I wanted was this part. And I knew that if we had this part, then we can make the rest of it. So yeah, help me out, AI, and yeah. Good.
Okay. Thank you, James.
Thank you, guys.
That was awesome. Everyone give one more hand.
Yeah.
And I welcome up Jonathan. Anyone do music in here? You? Oh, good. Do you also happen to be users of GitHub Actions? Ooh, we got one. We got two. Good. Then there's a lot of intersection between our first presentation and our next one. Anyone have any jokes? My ideal date? What is a robot's ideal date? Yeah, you can. Actually, you want to come up and you want to say it up here? You want to repeat it up here? Oh. Okay. Well, I'm stalling. Any other jokes?
Would you say you're a stall man?
I am a stallman. Was that a bathroom joke? Is that the?
That's a software joke.
Oh, it's over my head.
Richard Stall?
Oh, okay, that guy. What a bro. If only we can knew. If only. Do you remember your PIN? I think I know your PIN. Is it 1, 2, 3, 4?
Thanks for reminding me.
You're welcome. Give another hand to Jonathan.
All right, mic check. Ooh, Mike's here. Hi, Mike. All right. Today we're talking about getting started with GitHub Actions. I did something on GitHub Actions last time, is sort of talking about my experience validating 3D assets for a game pipeline. And this is going to be much more of like introductory, actually hands-on for me at least. So some live, less coding, more configuring, and going through some of the UI and giving you a chance to see if you did start using GitHub Actions, where might you look? What might you click on? What does it look like, and how would you start moving? So quick survey. Who here, I'll start from newest to most experienced. So who here has never used GitHub Actions before? OK, actually, let me go back one, too. Who isn't really sure what that is? OK. Who has used GitHub Actions and maybe like copy paste, that type of thing, not really made anything from scratch, but more just pulled stuff? OK. And then who here is relatively comfortable, more comfortable with GitHub Actions, making things? OK. So kind of broad spectrum. But there's a lot of people who hadn't even heard of it before. So that's cool. Who is interested in becoming more familiar than they are? Well, that's great. That is great. I'm so glad you're all here. All right. So this is an idea of me. I'm a software engineer. I have a studio, a game studio that I started. I'm the technical director of that game studio. Someone asked, AJ asked me, why don't you just say you're the CEO? I'm like, well, because that's not the stuff I do. I'm doing more technical stuff. I also do producer type things, so or project manager, like moving projects along. But a lot of it is, if it's technical, it's up to me to make sure that it works out, whether I'm recruiting someone or I'm doing it myself. So part of that is setting up a lot of standards and setting up pipelines to guide other people who are all collaborating together. It feels a lot like an open source project in that way, and a lot of the games are open source. So this is for software engineers who are interested in using or learning more about GitHub Actions. I'm glad there are many of you here. This is a project, the last project that I worked on, and this was the project where we ended up expanding out the pipeline. What I'll do is I'll get that started over here while we go back. And this is the repository that I worked on the last 3 months with 16 other people. 16 other people at least contributed to this particular game. And you can get some idea of this here on the left. Each of these is a workflow. I'm going to go more into details, but each of these is like the top level things you can configure for GitHub Actions. And this is kind of what it looks like when you're looking at these GitHub Actions on GitHub. So from a main repository page, typically you can see Actions on the top here. And if I go to another project, so let's just take a look at Facebook's React. You can see I'm on their Actions page. You can kind of see the different actions they have. So one of the things that's kind of cool is that you can actually easily see how other companies are set up if they have an open source project. So unlike some other tools, like let's say Jenkins. Has anyone ever heard of Jenkins? Or maybe if someone has something in-house that's just a little more tucked away, it's actually pretty easy to go and look at how other companies are setting up their GitHub Actions.
Can you zoom your browser just a little bit so I can read what something's actually?
Yeah. What works? Does this work or
Like +2, yeah.
+2? +2 to Zoom. OK.
Yeah, it's +.
Oh, and actually, let's just take a quick look at this game now. Let's see. That's probably going to take a second as well. It's loading up assets now, so we'll give it a sec. OK, so these are some brief examples. You can kind of read through this. On the left-hand side is the types of things that these workflows do, these actual workflows. On the right-hand side is the titles of these workflows. That's that list under GitHub Actions. These are not actions per se, but we'll get more into that. These are the list of the top-level configured workflows. And this is for the game. OK, and I'm going to pop back over here. Here we go. So I'm just going to show you really quick this. So in this game, for example, you see There's, that was a 3D environment, so there's a lot of 3D assets in there. Obviously, there's code running it as well. Worked with a lot of different artists. And let's see, anything else that would be checked? Yeah, so working on this project using GitHub Actions definitely helped do a lot of checks and do automated deployment. So it actually gets deployed onto this platform automatically. So that's one of the other things that's nice, is having this automated pipeline. OK, so let's take a look at why you might use GitHub Actions. So when you use GitHub already, so GitHub is required for GitHub Actions. So if you don't use GitHub at all and you have no intention of using GitHub Actions, it's really not going to help you at all. Whereas other CI/CD pipelines you could still use, like Jenkins, for example, even if you didn't use GitHub at all. You want to automate tasks that are related to your code. So you sometimes build something. You sometimes run tests. You run something that does something with your application. Deploy it somewhere, linting, anything like that. Any of that can be automated like this. One of the big things is having this in a shared environment is super helpful. So as I mentioned, you can go onto other people's GitHubs on their repositories, and you can actually see the actions in there. So if you're working on a team, having these things running in a more transparent way can be helpful, so that other people can kind of see what's going on. Other contributors can kind of see what's going on right there on the repository. It's not necessarily tucked away in some other server somewhere. So that's kind of helpful to make sure everyone's on the same page. And also that's different than running it on my environment, because it is helpful to run things like tests or linting and things like that on each person's computer. But it's also helpful to have those kinds of things in the shared environment. So I can see, for example, I have new contributors on a project. I can see that they keep pushing up code that's failing tests, right? And I can sort of see a pattern, and that gives me a chance to talk to them and say, oh, are you having trouble with the linter, or whatever it might be? It gives me the chance, as someone who's trying to guide other contributors, the chance to kind of see in a more clear way what they're running into, because we have these automated systems at a higher level. Whereas they might be running into something locally, it might be a blocker for them, but I might not be able to see that so clearly. So it's been helpful in that way. One of the great things about GitHub Actions is that if you have a public repository, it's free. You can use up all GitHub's money running. So you can do a lot of practice yourself, which is pretty cool. So the goals of this talk, one, I would like for you to be able to explain how GitHub Actions work by the end of this, and identify the main components of GitHub Actions, and recall the required components of a GitHub workflow specifically. And create a new workflow using the web interface. So we're going to go through each of the main components of GitHub Actions, just so we're all kind of on the same page in terms of the vocabulary. First one is GitHub Actions. What is that, and why is it called that? So that is what we looked at. That's the feature on GitHub. It's just called GitHub Actions. It's a catchy name. It sounds active, right? So it's this, everything you see, from down below Actions here. This is the Actions, UI. I can go look at. This is a workflow I'm looking at. These are runs of that workflow. And everything here, there's a lot actually like behind the scenes here, and you can dig in. You see this here. I could run this workflow on a certain branch. I can do filtering and everything. So there's a lot of features behind the surface, but the entire system of CI/CD pipelines, all the configurations that you can use, all of the components are all under the umbrella of GitHub Actions. The next thing is a workflow. And let me actually do this. There we go. So a workflow is one of these things. So these top level items here, each of these is a workflow. And what a workflow is, if you look at the code, like what is it actually? It is in this GitHub directory, always here, and always under workflows. So if you ever wanted to see what workflows does Facebook use for React, right? Each of these is a workflow for Facebook React. So I could take a look at this first workflow. These are all YAML files. So let's take a look at this first workflow. There's a lot going on here, so we don't necessarily need to understand these details. But just the fact that this is a YAML file, and this YAML file in this .github/workflows folder is a workflow. Workflows is just full of YAML files, each one a workflow. I'll pause for a second. Any questions about where we're at so far? OK. A job. A job is something that is a part of a workflow. So if I were to look in here, I could see jobs here. So at the top level of a workflow, it defines jobs. And that's absolutely required. If you had a workflow, but it had no jobs, it'd be like configuring something that did nothing, right? Like there's no real point of having one of these workflow files if there's no jobs in it. And a job is really flexible at that point. Once you get to the point where it's a job, you can have it kind of do whatever you want. Your job could do everything from A to Z. Now, an important thing about a job is that a job runs in a container. So by specifying this job here, this check access job, and this check maintainer job, it means those are running on two separate containers. So every job runs on its own container. It runs on its own runner. This runs on an Ubuntu latest runner. This other one over here doesn't necessarily specify. Yeah.
Difference between a runner and a container?
A runner is, like the container is the generic term.
Got it.
It's like saying container or Docker container.
Okay.
It is a GitHub runner, which truly is a container
Got it.
that runs a job. OK. Oh, you want it bigger? Ah, yes, of
Yes.
course. Is that better?
One more, please.
I am probably going to need to do some zoom in and out, maybe? OK. So is 150, was this OK? A little more? 175? Yeah. All right. I might have to go bigger and smaller. OK, so that's a job. Let's look at steps. So a job contains steps. So this check access job defines what steps it has. Each step is essentially steps is an array here. So YAML, thumbs up if you're super familiar with YAML.
Is this YAML?
This is YAML, yeah.
Oh, okay.
And then thumbs down if you're not super familiar. So OK. So I'll take this slide here. So these are JSON. Who's familiar with JSON? Thumbs down if you're not super familiar with JSON. OK, so some of us aren't familiar with JSON. No problem. So the way this works is this is sort of like a at the top level. It's like a bulleted list. You know, if you have a bulleted list, as you have nested items, it's like a hierarchy. Yeah. So hierarchy, nested, bulleted list. Yeah. OK. So if we kind of start by looking at this YAML file that way, then each time we're indenting, it's like they're sort of details about the top level item. Yeah. So this check access, this indentation, I think this is the only one under jobs that's at that indentation. So check access is this job, whereas this is a sibling at that level. So check maintainer is a sibling of check access because they're at the same indentation under jobs. Yeah. So we can follow here. So if runs on outputs and steps are all part of check access. And that brings us to steps here. So steps, each of these is steps is an array of steps. And each item in that array is identified by this hyphen. So this first step is just run this echo command. The next step is actually all of this stuff. Much more complicated, but this step has a name. This step has an ID, has a condition if run. Now a step should pretty much always have run. It's typical for a step to have a run. Doesn't necessarily always have to. Okay, let's go back. Okay, so that's steps. Steps are the real work that gets done. A step could be a command that gets run, right? Echo, you saw that one. It could be npm install. A lot of it, it's typically like or often, a one-line command or maybe a multi-line command, or it's executing a script. A step could call out to install dependencies.sh, something like that. But it is the most discrete unit of work inside a YAML, inside that YAML file. At that point, if you're running a script or you're running a GitHub action, which I'll talk about in a second, those are all things that are calling out. But
that could be any command line, any commands that we type on command line, we could call it a step.
yeah, that's right. It'll also support JavaScript right in there as well. So it supports an environment that's basically JavaScript with some special, like with a special GitHub environment. So it'll support that as well. But yeah, that's the smallest unit inside a workflow file. Yeah?
Would it be accurate to describe a GitHub action as a structured way to define a set of functions that you want to run and the conditions for when you run them inside of these containers like you described?
I mean, that's a pretty fair generic way to think about it. Yeah.
Yeah.
Yeah. OK, so an action, finally we're at actions, right? This is GitHub Actions. Finally we're at an action. So an action is a composable unit of work. And these steps being the smallest unit of work, instead of like having a command, echo something, npm install, whatever, right? Instead of that being some line of code, whether it's a shell script or whether it's a JavaScript or something, you can use an action. And there's a lot of examples of this as well. So let's take a look at over here, actions. Let's look at one of these probably uses an action. Here we go. Let's take a look at this file. So this file is called flag FBX files. So all this does is say if someone commits an FBX file, one of these kinds, it ends in FBX, then we want to do something. The idea is like this is a transitioning from one file format to another, just for context. So the idea is we don't want to use this type of file anymore. We want to use a different type of file. So if someone adds this kind of file, we say, are you sure you want to add that kind of file? I don't think we should be adding that type of file anymore. So that's really all that this is doing. But let's look at the action component. So under steps here, let's look at steps. And then let's look at this first step. OK, so this is one step. It's probably a little bit harder to read, so I'm going to unhighlight it. But that's the area we're looking at here. And it says uses. And it has this sort of path-looking thing, right? When a step says uses, and then it has that path, that is truly an action. This is this little composable unit that we're pulling in, and we're using it. So you can see there's this. I think I get a quick link to it. No, I don't necessarily. But I could look this up. In some interfaces, I get an easy link to this. Actually, I have. I'll pull it up here. So if I pull this up, should actually be able to just go to github.com, actions, change files. So this is the code for that action. So everything that's here is all being brought in and used. Here, let's actually look at like the parameters for this. There we go. So this is essentially the README for that, and changed files. And this is giving us an example. So these are a bunch of examples. They're showing us how to use it.
So is there something like a YAML file to schedule the workflow, to pick up one YAML after another, or all the YAMLs, or 5 YAMLs or something, and then to schedule the workflow and get the whole job done?
Yeah, kind of. So when you say, schedule the YAML, what I would say is those YAML files, each YAML file is a workflow. And what you can do is, in one single workflow, you can have many jobs that run in parallel, in sequence. You can also have one workflow trigger a separate workflow. So I think that it is possible to operate the way that you explained. Yeah. Does that answer your question? Yeah. Okay. Yeah.
Are actions like platform agnostic, like your workflow is running on Ubuntu?
Yeah.
How do you know that this action I can pull in and it will run on Ubuntu?
How do I know that? So typically, like most of them run on Linux. So Ubuntu is sort of the default for Linux. And how would I know that? I think the way that I would typically work is I would assume that, and then if it didn't work, I would figure out what was happening and realize like it's not a supported platform. So a real specific case though would be, okay, I need to make a Windows build of something, and for whatever reason, either it has to run on Windows or it's a lot better if it runs on Windows to make the build. Maybe I'm compiling something and I really want a Windows environment, just something like this. Typically, then I'm going to look for an action that's made to do that, and then I would run it on a Windows runner. So it would say runs on Windows x64 maybe. Does that answer your question? Yeah.
So then once you're in steps, you can't define another runner in the step to run it.
No. So the runner is defined at the job level. So the job runs on a certain type of runner. Yeah.
Do you have any tricks for doing debugging? Like when you go to that Windows environment that you've never worked on before and you have to do something?
Yeah. There are some tricks for debugging. Snapshots? I mean, you can. I was more thinking of either hopping into the environment, having having a script that is executable independently, meaning I actually run on a Windows environment. So so you're saying you're running on Linux. And
How do you debug Ubuntu then?
how do I do that? I use, so I'm on Windows. I have Docker Desktop. So I can hop right into something if I want to. And I can manually run command after command, right, rather than it being automated, just in case there's some, and I'll check the state between commands if I know I'm very surprised it's behaving a certain way. So, but basically getting interactive with it is incredibly helpful. Also, you can just turn your runners into verbose mode. So they will be spitting out lots more logging data in case there are actual logs that are occurring that will help answer your question. Those are some of the ways. Yeah. When you say snapshots, tell me a little bit more about how you would use snapshots.
Sure. You can do it in the actual virtual machine or Docker version, but essentially just have a clean build of what the environment is supposed to be, run through the action one by one, and see where you have unexpected behavior, and then identify that, oh, this had KB 8835 applied yesterday, now this action no longer works. Therefore, we need to either blacklist that update or fix whatever is broken by it. So you can go into GitHub Actions and download the snapshot, the entire snapshot of the entire container. Is that what you're saying? that's not necessarily what you could do through GitHub, but I use Git T, which is a fork of GitHub, but you can have, so in his image, he has Ubuntu latest. So maybe Ubuntu latest had a new update last night, and so now they've got, 25.10 out early, and that breaks your build. Well, if you go to 25, instead of using latest, you go to 25.04 or 25.04.3.
So you just try to reproduce the runner on your own machine. Is that what I'm hearing?
I try to reproduce the failure condition, or more accurately, I try to say, here is a good version. Does it still break? If it doesn't break here, then someone did something, and I don't care what they did with their thing. They should use the correct one.
Thanks.
So
More questions?
I'm just a little bit scared about this Ubuntu and all this stuff. All I have is Windows.
Yep.
And so if I have Docker desktop, I can get it all going.
Yeah.
Okay.
Yeah, you can debug everything. I say everything, not Mac. You can use Mac runners too, by the way. So you can't debug that locally if you're on Windows. But with Docker Desktop, you can actually run GitHub actions locally along with like local GitHub actions. I'll pull that up in a few minutes. And you can debug in that way, basically hopping into the environment, jump into that container interactive, and start executing steps one by one and inspecting the environment live. Does that answer your question?
Awesome.
Yeah, okay. More questions? Okay. Okay, so we were just looking at how you have a GitHub action let's go, that you're referring to inline. Right, so when we are here, and I mentioned this GitHub action. It's also versioned. These are that's basically a release version. You can also specify a SHA if you want, but it's very typical to just reference the version. And once we've identified that, then we could pass in parameters. This is, once you're using an action, then it's sort of like an interface with that action. So these are the parameters you're passing in here. So these are going to depend on the action. It's like calling a function. When you call a function, it's the function that determines what it needs. So once you're using a GitHub action, then you are going to go look up that action, and you're going to see what it needs, what it expects. If anything, many of them don't require these parameters, or these arguments, I guess. Okay, any questions about using these actions in this way, or how they serve as steps? Okay. Okay, so that's all the way down. Runner was the last thing. There are Mac runners, Windows runners, and Linux runners. And you can get a lot more specific. You can say that it should be an ARM-specific runner, right? So you can choose the architecture as well. And you can also use self-hosted runners, which you can register separately. So if you do have a private repository, but you're trying to not spend so much running them on GitHub, you can actually host your own runners, and you can basically register your runners with GitHub and use your own runners on your server. So you're not necessarily racking up a bill there. And also that allows you to create more custom environments. So that's more common in video games, or if you just have these really specific build environments that you want. So these are 3 VS Code extensions I strongly recommend if you use VS Code, if you're editing actions locally. And this middle one, the top one is essentially giving you feedback on whether or not you're following the YAML one plus the GitHub Actions one is giving you feedback on whether or not you're following the schema correctly. So it'll say, you have to have jobs. Your schema you're not matching the schema, right? You need a name. You don't need a name actually, but you need jobs. You need to have the on key, that type of thing. So it'll give you some of that feedback, and then also it'll actually show you, and I can show you this. It'll show you your remote runners. So if I open up this one, here we go, GitHub Actions. So it shows me, it's a pretty good local view of my workflows. So in this repository, I've got this deploy Jekyll workflow and this my first workflow. And I can even set up, I can even see like my environment variables here. I can see the runs that have occurred. So I get a pretty good view of what's going on with my GitHub Actions just by having this extension. Now this one is super cool. I have this set up on my machine at home. It is ACT is the command line tool that lets you run your GitHub Actions on your machine. You have to either be running on Linux or you have to have like Docker desktop installed. And it'll use the Docker containers locally. And that is tremendously helpful for debugging because that's exactly how I jump interactive with those containers. And that allows me to basically poke around and figure out whatever I need to figure out. And it gives you a lot less of the situations that look like, let's see, actions. Yeah. So like, what's a good one? Maybe one of these. Oh, down here. So if you don't have a way to test your actions locally and your actions are starting to get more complicated, a lot of the habit is just to keep pushing it up. I don't know if any of you have ever been there. You're like, I'm going to push it again. I'll push it again. I'll push it again. So this helps. So this is an example of when this one was actually just broken and I accidentally left it on. It wasn't disabled. So like, but it can look like this, just like over and over and over again. Just went back. Over and over and over again. Somebody's just like, oh, it failed, push, it failed. So it ends up looking like this, which is really messy. And typically you want to try to avoid a bunch of noise, right? Because some people get notifications if things are failing. So that's why GitHub local actions is really helpful for trying to do your best to work through all the bugs locally before you're pushing it onto the repository and like trying to debug it there. Okay, I'll pause for a second. Any lingering questions in the meantime? Yes, AJ?
Is Copilot good with actions?
Is it good with actions? Now, do you mean like making some new action, for example?
Yeah.
What we can do that. What's an example action that you might want?
Swear word checker.
Say again.
Swear word checker.
Okay, to what? Check the repo and see if there's any swear words in the repo?
Yeah.
How about this? Okay, cool. Let's see. Actually, okay, so let's just see this. Check. All right, so this is check for swearwords.yaml. This is how I'd make a new workflow. And let's, what's that? Yeah, of course. Is this okay? Okay, so check for swearwords.yaml. All right, so let's try, oops, why don't we use this? And we're in agent mode. We're gonna YOLO this. Let's see. So what is the goal? To check the repo to make sure there's no swear words in the repo? Okay. We'll see what it comes up with if it is either going to generate a list of swear words and you're going to see a bunch of swear words on screen.
Let's find out.
But let's see. I know there are actually libraries that are made for that type of thing, so it might pull that in. Create a GitHub workflow that checks the repo for any, oops.
List of words such as dog or cat.
For any swear words. It should fail if any words are found. Okay, here we go. And so we're in our workflow file. I would expect this to populate it. Hopefully it's a simple solution that we can sort of check pretty quickly. Yeah, this is not too bad. It's 31 total lines. There is some inline swear words. Oh, there we go. There you go. There are some swear words here. Wow. And no swear words found. Okay, so let's check this out really quick. Oh, here, forgot to add that. Okay.
You should add a swear word to your code base.
Say again.
You should add a swear word to one of your in your code somewhere.
I'll add a.
Somewhere.
I will add a not so bad swear word and then I'll type it. I feel a little bit hesitant to start.
Take
Oh.
this. It's not too bad.
Oh, that's true
You
actually.
can catch it.
Convert to main.
Oh, you're working with 11 other people. Who knows?
It's all. Well, this is a separate repo. It is actually here. So here we go. So I just pushed to GitHub Actions guide. Let's check out the actions that ran. So this actually failed. And let's see why it failed. If I go down, ooh, my screen is.
Checked itself.
It does. It might check itself.
Checked itself.
Yeah, yeah.
Checked its own file.
Yeah. There we go. This is great, though. We'll do it live. Okay. Yeah. So let's dig in. So it said it failed. Of course, we were pretty sure why. There you go. Right. They're there. It works. So what we can explain the error. What we can do though is let's check out this file. In fact, let's look at how the editor looks inside. So if I go to that workflow, the editor inside GitHub for these workflow files isn't bad. So let's check it out. So I can actually like search for things I want here. There's no way. Okay, yeah. And so what I actually want to do is I want to ignore. Let's see if I can do this. Ignore. Let's see, control space. I get autocomplete with control space in this editor, which is pretty nice. So you don't even necessarily have to install anything to get some helpful tooling. And this is like, I know, does that really say Gollum? We need the Gollum. Yes. Okay. So what do we have here? M must have the precious. So I'm surprised I'm not seeing. I feel like files. Okay, let's go. Let's look at this.
Hard code
Hard code
an if and
what?
hard code an if and
Oh, here we go. So let's look at flag FBX files. So this one has the workflow. Here we go, there. And this one has an example of how I'm filtering. Oh, paths. I was looking for match, but it's paths. OK. So under the, so I think ours was push. So pull request. Oh, no, it's pull request. Okay, push. We could say paths, and then this. Let's do actually ignore. Control space. Paths ignore. There we go. There we go. So let's do .github. I feel like that's probably good. Is this going to be? I'm not sure what pattern works. Maybe like a typical glob pattern.
Double star /star.
Just for good measure.
star YAML.
Oh, no, I'm not saying that's what you can have for your paths.
What's that?
You don't need it for your.
You just
Your
want to
ignore.
ignore the workflows check for swear words YAML, not everything.
Well, I was thinking,
It's just easier to go to the whole directory.
yeah. I mean, I can do this.
Paths, pattern.
Here, I could just do this. Workflows. There we go. Push pull request. Let's ignore.
Don't you need a star at the beginning before the dot?
No, because it's the root of the project.
Oh, okay.
Oh, I need a. It's got to be an array. I think.
Are your tick marks matching? The one
Oh, yeah, you're right. Thank you. There we go. Thank you. Yeah. Okay. I would expect this to work. Thumbs looks like that should match. Okay. Let's check it out. So this will count as another push to main. So it should, oh, pardon me, should run that again. So we already saw the fail case. That worked, right? It linted itself. Now we'll see, hopefully, a pass case where now that that's ignored, there we go. It passed. Okay. I'll leave it at that unless there's anything, I guess, questions, if you want to see anything in particular. Yeah.
I don't understand how it was able to check itself if it wasn't committed. I mean, it didn't reject its own commit?
It will. So when you add a workflow, it runs on that same commit. So if I add new tests,
Isn't there a chicken and egg problem here?
with what? Give me the scenario.
How does it know to run the workflow if it's not checked in?
It's all checked in as part of the workflow. It checks out the code.
The workflow is part of the code.
Okay, so the check-in happens first and then GitHub Actions run?
Yes, that's
and
correct.
Cache it?
That's correct. Yeah.
And so they block the branch from being merged?
That's right. Yeah. Whatever the rules are, but you can do that. Yeah.
And in this case, what were the rules? Did you check it in directly into main?
Yeah, it's checked directly into main. I was just pushing to
So
main.
it's just a failure, but it's already checked in, right?
In this case, yeah.
Like
But
it didn't prevent anything. I mean, it didn't
No.
basically prevent the swear words from contaminating the code base.
correct. But you can absolutely do that. That is
Okay, got you.
simple configuration to make that work. Yeah. So what we'll do is we'll add new tests, and because everything will typically come in from a pull request, if we add new tests and do a pull request, that if you set failing tests to block a merge, then in this case we would have had a pull request sitting there that could not be merged until, in this case, we fix the test because the test was kind of broken, right? In our case, so you have to fix the test in that case, and then you can merge. Yeah. Cool. More questions? Yeah.
When starting over, would you just use GitHub Copilot? I'm sorry, VS Code's Copilot to write the code as opposed to learning
Maybe for trying stuff, yeah. For trying stuff out, and this is helpful. Like when you're new to it, just going slow, getting used to that structure of the YAML, and trying to keep things simple. Because reducing your cognitive load as a learner is just so important to feel like you're making progress. And yeah, like making up some fun stuff, funny stuff, keeping yourself motivated with simple little workflows. And then, of course, you can have a conversation about it, right? And this is actually pretty helpful.
You could have asked it perhaps to can you figure out how to ignore your...
Oh, totally. Oh yeah. Ignore this file. Like this file itself has it totally would have done that. Yeah. One of the other things that's helpful, actually, what you're mentioning in terms of using like Copilot to kind of help out, if you have an error with like a pull request, let's see, let's go back to, this is going to show me runs of this, but I'll go to a different one. So build Godot game. Okay, so here's a failing run. What I can do is I can hop into one of these, and let's look at, let's see, web. I can have it explain to me what happened, which is pretty cool. So when you're new to this, if you have stuff failing and you're having some trouble, it's already on GitHub, right? Ideally, you're working through that locally, but if it's on GitHub, it's failing. You can do explain error, and it will be helpful. It's typically helpful. it'll do its best. Now, this Godot, I actually have this script actually was spitting out, it was in verbose, and it was spitting out many errors that were not fatal errors. I still had to fix them, but I still fixed them. I needed to fix them for my own sanity, but it did pollute this quite a bit. So this one was not correct, but I would say probably about half the time it's giving you some helpful information, particularly if you aren't super comfortable reading through. If this is like kind of overwhelming to start reading through all of the logs, it's a good way to almost like get some advice, right, on like what might have happened. Are there more questions? Yes?
If it's trivial, if not, we can do it like maybe at next talk.
Mm-hmm.
Can you export the square word checker into an action?
You can make it an action. I would say that's definitely not trivial. Typically, I would make a whole new repository for that.
Okay.
And that ends up kind of looking like this, just so that you can, so you imagine we take that shell script, we would put it into a repository like this. This would follow the rules, so it would have to kind of have a README with instructions and everything on how it would work. And then, okay, action.yaml. Defining inputs.
You could also just do a bash file action that says, hey, for each file in each of these, dynamically generate the list. And then just
Use it as like a local script.
A grep with a multi-parameter.
You're,
Dash E, dot, dot, dot.
you're saying set it up as a script in the repo?
I mean, you could just do it as, you could write it as a bash script, and then you could put that
Yeah, absolutely.
script as your action.
Could totally do that. Yeah, exactly.
Instead of a YAML.
Yeah, exactly. And then that would look like, okay, where is, oh yeah, I can do it from here. It would basically look like this. Instead of running this script, actually this is, let's see if this will do it. Move the checker into a check, into a separate .sh script and call that script on this step instead. So that's essentially, you could do that.
And that makes it work more portable. That way
Yeah, exactly, and it's easier to test.
the Ansible thing. Exactly.
There you go, and that's essentially what it would look like now. So now the actual checking is in that shell script. Is that? It's not a whole GitHub action, but it's a step in that direction. More questions? Okay. Well, thanks everyone. Oh, I'll just mention there are a couple of spots. Obviously going through the tools. Kind of playing with it. It's free, so that's kind of cool. And then these two are relatively helpful articles, and of course, just moving through looking at example actions is super helpful. So if you want to see these are some pretty nice articles for getting started as well. Thanks, everyone.
Thank you, Jonathan. Awesome. I will now go home and convert all of my shell scripts to actions. Probably. Okay, so why don't we give one more hand for Jonathan? Thank you. And actually hand for James, too. Thank you, James. Thanks to all our speakers. And now is announcements. So you can share anything you want. About 15 seconds, projects or ideas, events or activities, or just talk about yourself. Or your current Roman Empire and that meme. I don't think I understand it yet. But maybe someone could tell me about it in an announcement. Okay. Anyone show of hands? Edward, come on up.
Kind of unrelated, but I thought I'd ask. I'm looking for a dog sitter. I will sit in return. So I'm in San Marcos.
Yeah, clap, clap. Any dog sitters? Go. Ooh, we got one. Any other announcements? Oh, come on up, please.
Hello. Hey, my name's Glenn. I'm working on an app called Podscriber. It's just about ready to launch in the next 2 weeks or so. I'm just finishing up the UI on the admin dashboard right now. It's basically a transcription and marketing app for podcasters. So if anyone has a podcast or knows someone who has a podcast, I'd love to hear from you. It's getting ready to do a closed alpha launch upcoming. Thanks.
Thank you, thank you. Anyone else?
I'm Hobson Lane, just published the second edition of Natural Language Processing in Action. It's updated to talk about LLMs, but it's focused more on the foundational skills of NLP, doing AI the old-fashioned way. So.
Very good. Coming up?
Hey, this is kind of a request. My name's Andre Hoth. I'm working on an app that converts glucose data into musical passages to sort of alleviate alarm fatigue for mostly adolescent glucose patients. But I'm about to convert my code base from React Native probably over into Unity because there ended up being a lot of cool particle effects and interactivity and a lot, not hundreds, but thousands of graphic elements on the screen at once, and my frame rate was... So if there's anybody who knows how to increase frame rate with a lot of interactive graphic elements in React Native, I've looked at Skia as perhaps one option, but it seemed like there were still some blocks there. Please seek me out and say, hey, do it this way instead of moving over to a game engine before I take that big step. I appreciate it.
Thank you. Okay. Anyone else? Oh, you're closer. Sorry. You're next. Come on up.
Hi, everyone. My name is Brian. I'm a student studying computer science. I'm interested in the mobile development space. My passion project is probably an app to help people develop social connections throughout their life journey. But I just want to grow in mobile technology. Anybody who is interested in connecting, I'm happy to connect with you. Thank you.
Thank you. Come on up.
Hi, I'm Marissa. I'm a software engineer at homes.com, and I'm also a master's candidate at Berkeley. And I want to connect with everyone because I just moved to San Diego, so I'm looking to connect with more people in the tech space. And my current Roman empire is vibe coding, so I'm making a web app right now called Crash Out, based off the Gen Z term, I'm Gen Z, but Crash Out, which uses AI, uses the open AI model to analyze text whether or not it thinks you should crash out or not. So, yeah, hope to connect. Thank you.
Thank you. Coming up?
Go Bears. I went to Berkeley as well. I'm here because I'm studying Python, and I just love the tech field. Everyone here is so passionate and dynamic. It just gives me a lot of energy being here. If anyone wants to connect about learning Python or data science, I would love to speak more with you. I've been collecting a lot of resources to study Python and also local meetups in this field. Currently, I'm a project manager at Rady Children's Hospital, where information sciences or library sciences have made the most impact. And so that's kind of fed into my overall interest in just getting better at learning, getting better turning information into insights. So if anyone wants to connect and talk nerd out together, happy to do so. Thank you.
Awesome. Go ahead, James.
Yeah, to follow up on learning Python and stuff like that, do check out SD Python. They have a study group that is on in the mornings. Yeah, I guess one of the folks is here. But they have a study group that is Saturday mornings. I think it's 10. Just need to be a member of their Discord. They're very active. It's every week, Saturday at 10, and then also they do a meetup every month. So yeah, Python is definitely in the house. Yeah.
Awesome. Anyone else? Okay. Well, that was our announcements. Go ahead and follow us at DEVx.network. We pushed a new site today. It looks a lot better. Submit your talk, join the Discord community, and follow our event calendar on Luma. Thank you.